Okay. Hello and welcome everyone to problem solving session for NPTEL course, problem solving through programming in C. This is week 12 and also the last week. Today we are going to look at problems related to structures and pointers. So first, as usual, we are going to go through multiple choice questions and then we are going to look at 4 programming questions. So starting from the quiz questions, I will let you I'll give you time to read the problem and then I expect you to try to answer the problem. So you can write your answers either in the chat box or you can let me know by unmuting yourself. So here the first problem is, which of the following are themselves a collection of different data types? So it's asking which of the following is a collection of different data types. First is string, then array, character, or structure. Right, so correct answer is structure, because in that you can have different variables of different data types. Okay, second one is, which of the following comments about the usage of structures is true? First is, a storage class can be assigned to individual members. Second, individual members can be initialized within a structure type declaration. C is, the scope of the member name is confined to the particular structure within which it is defined. And D is none of the above. So any answers? B, C, okay. Okay, option B says that individual members can be initialized within a structure type declaration. It is not true, because when you declare a structure, inside that if you have two, let's say two members, int A and int B, then inside that structure you do not give them values. Only when you create an object of type of that structure, then you assign values to it. So B is not correct. Option C uh, is correct. It is saying that the scope of member name is confined to the particular structure within which it is defined. So if there is a member named X, then that X variable can be used only within the scope of that structure. You cannot use it without using the structure name. You have to use the structure name along with the dot operator to access that member, and the scope of that member name is confined to that particular structure. So C is correct. And option A is, storage class can be assigned to individual member. Now what are storage classes? So there are 4 storage classes in C language. Here I have opened this. There are these 4 storage classes in C language. First is auto, then there is extern, static, and register. So when you specify auto storage specifier before a variable, say you can write auto int x, then what does that mean is that it will be stored on stack, initial value will be garbage, the scope is within the block, and its lifetime will end at the block. So by default, uh, the storage specifier is auto for variables within a function. Then there is extern. When you want some variable to be available, like to be accessible, like outside a file as well, like it should be globally visible across multiple files, then you use extern storage specifier, which is like scope is global, it is along across multiple files, and its lifetime is till the end of the program. Then there is static storage specifier, which is which the scope of which is within the block. That is, if you have declared a variable name like static int x inside a function, then it is accessible only inside that function. However, it is its lifetime is till the end of the program, means once you have initialized it and changed its value, you whenever, even if you re-enter that function again, its value remains. If x is equal to 5 when you entered it first time, then if you change it to 6, then if you enter the function again, it remains 6. So that's how its lifetime is till the end of the program. And the register storage class means that the value will be kept in the CPU register, means the physical register which is there in your processor. It's not in the RAM, it's in the register. Okay, and its scope is also till within the block till the end of the block. So the question here is saying that the storage class can be assigned to individual members. It's not true. So if you, when you declare a structure, inside that you cannot write static int x or extern int x. So you cannot give a storage class to individual members in a structure. So here the option C is correct, that the scope of the member name is confined to the particular structure. Now problem 3 is, if you have any question, you can stop me or you can write them in the chat box. I continuously monitor the chat box. So you can either write there or you can unmute yourself and ask. So problem 3, what is actually passed if you pass a structure variable to a function? So just to clarify the question, so if you have declare a function and one of the parameters or the arguments to that function is a structure variable, then it is asking, then what is actually passed? Options are A, copy of structure variable, B is reference of structure variable, C is starting address of structure variable, and D is the ending address of structure variable. Okay, so I've got two answers. Option B, okay, reference of structure variable. Okay, so here the correct answer is option A. It's a copy of the structure variable. Means if you pass, if it's a copy, means it is not the original structure object. It is a new structure object which is exactly a copy of this. So there are now two same structures in the memory. If you wanted to pass structure variable A, it will be copied to a different location, which is now accessible inside that function. So it's a copy, it's not a reference. Reference would mean that it points to the original object. It doesn't point to the original object if you are only passing a structure variable. If you want to pass a reference, then you will have to pass the address of the structure. Then you can access the original structure. It's similar to if you pass a integer variable. If you pass an integer variable, you are passing a copy of that variable, not the original integer variable. If you want to that integer variable is modifiable in that function, then you have to pass it as a pointer. You have to pass the address of that integer. So correct answer here is option A, copy of structure variable. Moving on, problem 4. Here it says that the program will allocate dash bytes to pointer. So you have to tell how many bytes will be allocated to PTR. Assuming that the size of an integer is 4 bytes. Okay, here you have first declared a variable PTR, which is a pointer to an integer. Then you are here initializing it by mallocing like a block of memory, and the size of that block of memory here you have specified as size of int multiplied by 4, and malloc actually returns a void pointer and you want to assign it to integer pointer, so you have done here typecasting, okay, to an integer pointer. Then in the next line you have called realloc, which is another dynamic memory allocation function similar to malloc. So here it is, you are passing it here ptr, and you're also giving it the size of the memory block that you want to allocate. Okay, then this is ptr. So now here you want, the question is asking you what is the size of the memory block pointed to by ptr. So your program is allocating some chunk of memory and ptr is pointing to that. Question is asking what is the size of that memory block which is pointed by ptr. And you should use the information that the size of integer is 4. So I got one answer 24. That is not correct. Can you try again? Eight bytes. Okay. 128 bytes. Okay, so 0. Okay. 8. 52. Okay. So here actually the answer is 8 bytes. So I'll just quickly go to a page where they have explained about these different dynamic memory allocations. So I'll start from the beginning, like from malloc. Okay. So therefore, so why is dynamic memory allocation anyway required? So it's required because when you write a program, you might not know how much memory your program may require. Like it depends on the input that the user is giving, or the data that you have to process, which can be dynamic in nature. So you may expect initially that's okay, 100 byte, maybe your array should be of size 100, but later you might get more data and you need to add that data to your array. So then you will have to resize your array so that you can add additional data in the array. At that time, dynamic memory allocation functions are important. So these dynamic memory allocation functions like malloc, alloc, free, realloc, these are defined in library, okay, which is this std library, standard library, okay, header file. You have to use this header file if you want to make use of these dynamic memory allocation functions. So there are these three main functions. One is this malloc, alloc, realloc, and then free is also very important. It is this basically deallocates the memory that you have allocated. So first is malloc, which stands for memory allocation. Okay, it allocates a large single contiguous block of memory. Okay, it's contiguous, and you have to specify the size, and then it will allocate that memory and it will return a pointer to that memory, and the pointer is by default, like not by default, the pointer is actually a void pointer, so you have to cast it into a pointer of your data type. Okay, so this is the like format you have to write this is the syntax. You have to write malloc, then you have to specify the size in bytes, okay, and then you have to cast it to the type of the pointer. So this is here an example like malloc, then you have specified the size in bytes, that is 100 into size of int. So size of int is 4, so this will be 400 bytes. You want to allocate 400 bytes of memory, and then you have typecasted here. So this memory, whatever the size is, here in this example it is 20 bytes, it is like contiguous block of memory, and PTR is the address of the first byte in that block. Okay, this is your malloc. Then calloc. Calloc stands for contiguous allocation. So it is also similar to malloc, but differs from malloc in two ways. First is that it initializes each block with a default value 0. Okay, so every byte, like not just byte level, so since it's saying every block, so then you have to specify the element size also. Like if the element is an integer, character, float, etc., and then it will initialize every element as default value 0. Okay, so this is how it will look in memory, that this is a block of memory which is divided into, like it's a contiguous memory divided into blocks where every block is initialized to 0. And PTR now points to the first byte in this contiguous chunk of memory again. Okay, so here there are two parameters. First parameter here is the size. First parameter is the number of elements that you want to allocate, and then next one is the size of the element. Okay, n is the number of element and element size is the size of each element. Then there is free. So free is used to deallocate the memory which you have allocated already. It is very important to deallocate the memory which is no longer required by the program. It helps you to, because if you have already allocated it once and you don't deallocate it, then the program cannot reuse that memory. Okay, even if it is not required. So in C there is no in C it is the responsibility of the programmer, that is you, to deallocate the memory that you have allocated unlike other languages like Java. Okay, so here when you say free PTR, it will basically free that memory will be again reusable. Okay, it is like it is going back to some place where it is marked as free. Now the last one here is realloc, which stands for reallocation. Okay, which is dynamically reallocate memory. So it is used to resize a memory which has already been allocated by malloc or calloc. Okay, so here let's say the pointer initially you mallocked some 20 bytes of memory, and now you want to increase that memory, so you can specify the pointer which is pointing to that mallocked region, and you can specify the new size. Okay, here earlier it was 5 into size of int, which was 20 bytes. Now you're saying, okay, 10 into size of int, that is 40 bytes. So now the new size of this block is 40 bytes. So in this question here, initially you mallocked, okay, so you mallocked size of int into 4, that is 4 into 4, 16 bytes of memory. Okay, then you are, which is pointed to by pointer PTR, then you are calling realloc, passing PTR, and the second argument is size of int into 2. So now you are saying, okay, resize it to this size, which is 4 into 2, 8 bytes. Originally it was 16 bytes here when you mallocked. Now after reallocation it is 8 bytes. You have reduced the size. So it's not like you always have to increase the size. Here it is reducing the size. And as you can observe here, also in this example, this is the size. So this is the new size. Okay, this is the new size which is going to be allocated. It's not like getting added to it. It's the new size. Is that clear? So that's why PTR is now pointing to a block of memory which is 8 bytes. Okay. Okay, moving on. Problem 5 is find the output of the following program. Here I will let you look at the program and I would wait for you to tell me which of the four options. There are four options on the right hand side and you have to tell me which is the correct option. Okay, there are two answers so far, A and B. I'll wait for more answers. Option D. So regarding the exam pattern, I think there will be programming question. You can expect around maybe 2 programming questions. I'm not sure about the pattern. This was from last year. I think there were 2 programming questions. I'm not sure if there were any quiz questions or not. But I don't know what is going to be the pattern this year. Okay. Okay, I'll just explain it in one like few minutes, like just now. I'm just jotting it down. Okay, so here the correct answer is option B. Okay, BCT. And before I explain this, but like, okay, let's look at it. First, we have A, which is the array of characters, and this is we have initialized this by using this set of curly braces and writing this. Okay. Now P is a pointer to a character. So now we have initialized it with A, that is the address of the first element in the array. Okay, so P is initialized to the address to like A. What is A? A is the address of the array A, right? And the address of array A is also the address of the first element in the array. That is this A, small a here. Okay, now when you say plus plus P, so you are incrementing the pointer pointing to the say starting address of the array. So when you say plus plus P, so P will be incremented by the size of the elements. So here the size of element is 1 byte. So like character, so elements are character, so the pointer P will be incremented by size of character and it will point to the next element, that is next character. So now after this statement, third statement, plus plus P, P points to B. I will write it. Okay, I'll explain it here anyways. So Yeah. So after this second line, P is pointing here, okay, to the beginning of the array and also the first element of the array. When you say P plus plus, now it is pointing to the second element of the array, that is P. Now you have a while loop here, and the while loop is saying, okay, while star P, that is the, what is star? Star is dereference operator, which you can read as, like you can read star as value at PTR, value at address pointed by, here P, I'll use P, okay, because you are writing star P. So you can read it like star P as value at address pointed by P. So value at address pointed by P, star P, is not equal to E. That is, you have to continue in this loop until the value at pointer P becomes equal to E. Okay. Then right now you are at, your pointer P is pointing to second element, and the value here at this address is B. Okay, value here is B. B is not equal to E, right? B is not equal to E, which is true. So since it is true, you will go inside the loop. Okay, when you go inside the loop, there is a print statement. Now what is the print statement argument? Is it is star P plus plus. So here you have two operators. One is the star diff reference, and plus plus is your postfix increment operator. So your postfix increment operator plus plus has higher precedence than the dereference operator. So this, now how will this be computed? Now this will, here first it is going to compute like P plus plus and then star. But as you might know already, that when you say P plus plus, the value of P which is going to be used here for dereference is going to be the value, original value of P. Like I'll just, it is 100, 101. I'm just giving them some random addresses, contiguous addresses, because there are in array, right? And each character I'm assuming is of size 1 bytes. So first address is starting from 100, second is 101, and so on. So currently your P is pointing here, that is P is 101. So when you will solve this, you will use like value at 101, which is B, that is going to be printed, and after that you are going to increment P. Okay, so here after this statement it will print actually B, and P will be changed to 102. P will be incremented because of the postfix increment, but the increment will happen later, and the value which is going to be used is 101, the original value of P. Okay, that you have to like be careful about. Okay, so here the first print will print B, right? Then you will again go in the while loop. Now when you go again in the while loop, now the value of P, what is the value of P here? Value of P, because you changed it, like incremented it, now value of P is 102. Now star P means what is the value at address pointed by P, which is 102. So value is C. Is so here it's the condition is C is not equal to E. it's true. So you will again go inside the while loop. Here you are going to again execute this print statement. So it is again like star p plus plus, right? But p now is 102. So what are you going to print? You're going to print the value at 102, which is C. And then P is incremented. So P becomes 103. Now again go back to the while loop condition. But now P points here to address 103. So P here now is 100 and sorry color. P is here 103. Now what is value at address 103? It is D. So D not equal to E is true. So you will again go inside. You will again do the same thing, but P is now 103. So what is going to be printed? Value at 103, which is D. So it will print D and it will be incremented to 104. Then you will again go here. It is P is 104. Now value at 104 is E. Now it's E. Okay. And E not equal to E will become false because E is equal to E. So then it will come out. But so far it has printed B, C and D. Okay. So B, C, D were printed and that's why that is the answer. Is that clear? Any questions? Okay. So here answer is option B. Now moving on. Just I think it's okay if we just revise this with another example. This is one of the most confusing. This can be one of the more like working with pointers can be one of the most confusing things when you are learning C for the first time. So here you can like these operators plus plus star can come in these three different forms. So in this question we had this in the star p plus plus form, right? But you can have it in two other forms here, like plus plus star p plus plus and star plus plus p. So what is the difference between all of these? So let's look at that via an example from this website. So here first star p, as I explained, it represents the value stored in that pointer. Okay, plus plus is the increment operator here, which has two forms. One is prefix, another is postfix. Okay, so the precedence of prefix plus plus and star is same. Okay, the precedence of prefix plus plus, when p plus plus is coming before the variable, prefix plus plus and star is same, and both are right to left associative. Okay, while the precedence of postfix plus plus is higher than both the prefix plus plus and star, and its associativity is left to right. So with this information, let's try to understand the difference between these three forms. And for that, we have here an example. First is here is an array of integers, and the values here are 20, 30, 40. Okay, so there are three value, the array size is 3, right? There are three integers in this array, and there are 20, the values are 20, 30, 40. Then you have declared here a pointer to an integer p, and initialize it to ARR, that is the name of this array, and name of the array is the starting address of the array, or you can also say the address of the first element in the array. Okay, those two are same. So it is pointing to the first byte in the array, and it is pointing to the first element, which is 20 here. Now there is another variable q. Now you are computing the value of these like plus plus star p etc in q, and then you are going to print them and see what are they. So first is q is plus plus star p. So recall that the precedence of the prefix plus plus and star is same, right? Now since the precedence is same, so you have to so then associativity is important here, and the associativity is right to left. So since the associativity is, I'll just refresh the page. Okay, so here associativity is right to left. So first star p will be computed. So star p means value at p. P is pointing to the first array element. So value at p, what is that? That is 20, right? Then you are incrementing that value. Okay, now that value will become 21. So incrementing that value, and you're storing that in q. Okay, so q will be, q is 21 now. Q is 21. And that so since it is a pointer operation, like you are operating with pointer here, right? You are saying okay, so here the increment is not only increment is actually happening in the array. So the array value is also going to be changed from 20 to 21 here after this. So this will become 21. And if you're going to print q, that will be printed as 21. So if you print star p, p here p was not incremented, the value was incremented. Okay, p was not incremented, p is still pointing to the first element. So when you say star p, it will print 21, and if you say what is q, then that will also print 21. Now this is, remember that this is now a changed array. You have changed something in the array. It's not same as original 20. Now the array is 21, 30, 40. Okay, so now if you on this new array, you do the next operation, that is star p plus plus, which is same as in the question. Okay, so here plus plus is your postfix operator. So first this will happen, right? But since it is a postfix increment, so increment the value of p which is going to be used is the original value. Okay, that will be used to dereference p, dereference, right? But then p will be incremented. So here q will get the value at p. Where is p pointing? P is still pointing to the first elements. So q will be 21. But p will be incremented to the next position. That is, it will now point to 30. So if you now say what is the value at p, it is 30. And what is q? Q is 21. Then last is star plus plus p. Okay, here you will first increment the value of p. Okay, increment the pointer. So now currently it is pointing to 30. When you increment it, it will now point to 40. So then you dereference it. Here then you are saying okay star. So then the value here is 40. So q will now have value 40. So p is pointing to 40, q also got 40. So now if you say star of p, it will be 40. And what is in q? That is also 40. So is there any question with this example? Are these three different forms clear? If not, you should go back and look at it. It's like just Google it and you will find. It's important to understand the difference and to understand how the postfix increment, prefix increment works. Okay. So next one is an easy question. So the problem is here you have structure XYZ. Okay. You have declared it here. It has only one integer a. Then you here create a variable object1, okay, of type struct XYZ, and here you have initialized it with value 1. So a member a in this structure will get value 1. After that, you create another object of structure XYZ type, and that name is object2, and you here use the assignment operator and you like make a copy of object1. Okay, it will make a copy basically, assignment operator. Then here you are printing the value of object2 dot a. Then you are changing the value of the variable like the member a in object2, and then you are printing the value of member a in object1 and object2. There is no new line operator, so everything will be printed without any spaces or new line here, and these are your options and you have to tell which is the correct option. Yeah. So I don't have any information about the exam pattern or how many marks are required to get a certificate. For those such questions, I think you can write on the course website, and probably you will get answers there. Okay, so for this question correct, all of you have given the correct answer, which is option A. And is any one of you would like to unmute and explain why it is option A? Okay, so I'll explain. First, object2 is a copy of object1. So object2 will also, in object2 also, the member A will get value 1, right? Here, so when you print object2 dot a, it will print 1. But then you change object2 dot a equal to 100. Now, since this was a copy, these are two different objects. They're not like object2 is not pointing to object1. Okay, it's not a reference. They are two different objects. So when you change member a in object2, that only changes the member a of object2 and not of object1. That's the only thing you need to remember here. And so that's why when you print object1 dot a, it is still 1, and if you print object2 dot a, it will be 100 because it was changed in this line. So the correct answer, like here, this line will print 1, this will print 1, last line will print 100. So correct answer will be 100, which is option A. Moving on. So this is again a little tricky question, and here the question is asking the output of the following C code. Assume that the address of X, so X here is a two-dimensional array. Okay, it is saying the address of X, that is the base address of this two-dimensional array, is 2000, and an integer requires 4 bytes of memory. Then what will be the output of this program? So this is your print statement, and you have to tell what will be the output of this print statement. So I've got two answers. Any other answers? Okay. Okay, anybody, any other answer? Okay. Okay. Uh, I can wait for just a few more seconds for others to try. All right, so I think we have got three correct answers here. So option A is correct. It is 2036. All of the prints is, and so one of the answers is option D, which I understand why you think can be a correct answer. So now let's look at, I'll just go, okay, I'll explain this. So first, X is a two-dimensional array, okay? So when you say X here, okay, this is actually, now here you're doing X plus 3. It's a pointer arithmetic. I think you understand that. Then it's like a pointer arithmetic, right? In one-dimensional array, if you have, I'll just use my whiteboard here. Okay. Let's say you have a array A. Okay. Just use, no need to no need to initialize it. Here, this is your one-dimensional array, okay, which has 5 elements. So when you write A, that is the base address. Okay, when you write A plus 1, that is the, and also address of first element, right? When you say, when you say A plus 1, like add 1 in A, so here the element in this case is an integer. So when you say plus 1, it is incrementing the address by the size of the element, and this element here is integer. So it will now, if the address was here say 100, and if the size of an integer is 4 bytes, then after A plus 1 it will become 104. Okay, and now this is, and since in array all the elements are contiguously located, first element, like the first integer is at address 100, second will be at 104, third is at 108, then 112, 116. Okay, so they are contiguously allocated like this. So this is then the address of first element. No, I should not say first element, second element. You can also say them 0, the first element, if the indexing, like according to the index, I'm using the indexing like first element, second element. Okay, now this is for a 1D array. Now what happens in a 2D array? Now if you have B, say 5, 3. Or if we take same example as question, it is 4, 3. So it has now 4 rows, 3 columns. Okay, now your array is actually going to be something like I think you understand, right? So your array is like this here. So it is still contiguous in memory. Every row is I'm assuming here is a row wise allocation. Okay, your array is stored in row wise order. First row, this is your first row, second row, third row, fourth row. Now when you say B is the base address of your 2D array. It is address of first row, or you can also say it is the address of first element. First element, like I mean say by first element I mean B00. Okay, so it is the address, base address. It is also the address of first row. It is the address of first element. Only the address I'm saying. Okay, now when you say B plus 1, now B here is a two-dimensional array. Okay, just I have to connect my chargers. Okay, here the element type in this case is a 1D array. Okay, it's a 2D, B is a 2D array, and every element here is another 1D array. So B is here. For initially B you're saying is here. Okay, this is B. When you say B plus 1, it will be incremented to point to the second row. Okay, this will be address of second row. When you say B plus 2, it will be address of the third row, right? Then if you will, what is there? Star. Now when you say B plus 1 star, what is that? Is that a value? So it is like B is the address at the level of this 2D array. When you say star B, now that is an address inside a row. Okay, it is still an address. So that is now the address of first element in second row. This will be address of first element in second row. When you will use 2 star star, that will be the value of first element in second row. Okay, I'll just remove some confusing statements maybe. These are this can be a bit confusing, I think. Huh. So I'll just go over it again once. So if B is a two-dimensional array with 4 rows, 3 columns, then this is the this is basically the layout you can be, which can be in your memory. Okay, where each one of these are a row, first row, second row, third row, fourth row. When you say B, so B is the base address of this two-dimensional array, which is the same as the address of the first row. Okay, when you say B plus 1, you are incrementing by row. Okay, complete row. So like complete 3 elements, 3 integers will be skipped. So now it will be the address of second row. When you say star B plus 1, that will be the address of first element in the second row. which is this element here. Okay, when you say star star b plus 1, that will be the value of first element in the second row. That's the value, not address. So if we have to take a concrete example here, like if b is 2000 here, okay, what is b plus 1? So 2000 plus the row size is here 3 into integer size, the element size, integer size 4. So it will be 2012. Okay, this will be here 2012, right? Then address of first element in second row, that is same as this, and the value can be something here, maybe 10. So this will be 10. Now if you, is there any question here? So coming to question here, problem here, if you understood that, then I'll just explain it here that, okay, x is currently 2000. Okay, when you say x plus 3, so you are skipping 3 rows, right? So this was x here, x plus 1, x plus 2, x plus 3 will be here. You're skipping all these 3 rows. So 3 rows you're skipping. Everyone, each of these 3 rows has 3 elements, right? And of size 4. So it will be 2000 plus 3 into 3 into 4. Yeah. I hope you understand. If you don't, then just let me know. Okay. You're skipping these, like basically add all of these elements that you're skipping. That's same, right? You're skipping 3 rows, each has 3 elements, every element is of 4 bytes. So you're skipping 3 into 3 into 4 bytes, which is 36 bytes. So this will be 2000 plus 36, so 2036. Then as I just explained, when you use one star, that is still the address, it's not the value. So it is same as this, but it's a address of this first element here in the fourth row. Okay, so this is also 2036. Then the last one is x plus 2. So you're skipping 2 rows, you're coming here and you're saying, okay, now I am at 7. Now you're saying star. So star means the address of 7. Now you are at the address of 7. So star x plus 2 is the address of 7. And it's very important, and I think this was not clear from my explanation, but it will be clear here now. Now when you do plus 3, now this plus 3 will be according to the size of the element, and here the address is pointing to a integer. So when you do plus 3, this plus 3 will be according to integers. So you're going to skip 3 integers here. Okay, like you're going to add, so to this you are here, right? You will add 1 2 3, so you will reach here. Now this is still an address but to an integer, and now it is pointing here, but the address is that value 2036. So you should like you should remember that x is actually here a, like it's a double pointer like star star, and here it's a 2-dimensional array. So when you say x, x is actually the base address, which is also the address of the first row. And when you say x plus 1, you are skipping rows. Okay, when you say pointer arithmetic on this x, you will the element size by which it is incremented is the row size. Similarly, you can, I think you can go and work out this for 3-dimensional arrays. Okay, is there any question? Okay, moving on. What does FP point to in this program? Okay, you have this program. Here you have file star FP. FP is equal to F open hello R. Okay, and these are your options. A is the first character in the file. Second is like these are option for what does FP point to. Okay, so first option is saying that FP points to first character in the file. Option B says it's a structure which contains a character pointer which points to the first character in the file. Then C says it's the name of the file, and D says it's the last character in the file. Is my voice not clear? Okay, is my voice clear? Okay, okay, thank you. Yeah, so our correct answer is option B. So for FP, which is like a pointer to a file, so it's actually a structure, so which contains information about the file. Like here, it can contain information like the file path, the permissions on the file. Here you have given the file path, which is hello, right? File name here you have given as hello, and then you have given that the file permission is read, so you want to open the file with read permission here, and it has other informations also, like in like when you first open a file, it will point to the start of the file, which is the first character of the file. Okay, as you read the file, then that pointer will be changed and that information will be there in the structure. So it's a structure. Why a structure? Because you need to record a lot of information like the name of the file, the permissions of the file, the location of the like read pointer, write pointer in the file, etc. So it's a structure which contains in which one of the members, like which contains a character pointer which points to the first character of a file. So option B is correct here. Okay. Okay, so the question here is asking, like, this is related to file handling in C. So if you want your program to open a file and read it, or if you want to open a file, write it, etc., then you have to use, you can use this library function, like similar to other library functions, printf, malloc, etc. There are library functions available to open and write up, open, close, write, etc. Okay, so fopen, this library function allows you to open a file and you specify the name of the file and the permission on that file. Okay, so here it is saying, okay, open the file with name hello and open it for read only. Okay, you cannot write it because you have not given here write permission, so read only. And it, this fopen library will return to you a structure. Okay, that structure will have information such as the like what is the permission, etc., because that needs to be checked, that may need to be required to be checked later in the program. So it will have it is a structure in which one of the members is a character pointer. Okay, and initially when it returns, fopen returns, that pointer points to the first character of the file. Okay, because that is logical, right? You're the for any, like when you open the file, your pointer should be at the first character of the file. Okay, okay. Moving on. So I have a very simple question here. Which of the following operators can be applied on structure variables?
Option C.
Any other answers? Okay. Option D, D. B. C. Okay. Okay. So it's saying which of the operators can be applied on structure variables. So option B says assignment operator. I think we have already seen here, like we created this object 2 of type struct xyz. We use the assignment operator here to initialize it to object 1, right? We created like a copy here. So you can definitely use the assignment operator. Then option A is equality operator. So equality operator you cannot use here. To like equality operator, basically you want to use to compare whether two structures are equal or not, but that is not allowed in C. You cannot use equal equal, like is object 1 equal to object 2. No, you cannot do that. If you want to check the equality, then you'll have to do it by member. Okay, you'll have to check the equality of each member. So option B is correct, that you can only use the assignment operator on structure variables. Okay.
Why we can't choose equality operator, for example, A double equal to B.
Sorry, can you repeat?
Why we can't choose equality operator in C on structure variables?
That is not defined in C standard. Like you can't do that. For that it has to be defined in C. The language runtime needs to be able to do that for you, but it doesn't do that for you.
Okay, ma'am. Please give any example about structure variable.
Okay. Yeah, here in this problem we have declared a structure struct xyz with member int a, and then we created a variable here object 1 of type struct xyz, and it was initialized with this like 1. So member a has value 1. So object 1 here is a structure variable. Okay, so problem number 10, you have to tell the output of this program. Here you have a structure P with two members, index and character Y. Okay. And then here you have P1, which is an array of struct P. Okay. P1 is an array of where each P1 is an array of structures. Okay. And this is how you have initialized this. Basically, when you use this initialization list, okay, then the first two values are going to be used to initialize the members in the first structure. Okay, the next two values are used to initialize the members in the second structure. So in the first structure, x is equal to 1, y is equal to 90. Then in the second structure, x is equal to 62, y is equal to 33. And last structure, x is equal to 3, y is 34. Then you have declared here a pointer ptr1, which is a pointer to a structure. Okay, you have initialized it to p1, and then you are calculating x, which is as the size of p1, that is the size of this array, okay, of structures, divided by 3. And then you have a statement which is checking if x is equal to the size of integer plus size of character, then you have to print true, otherwise print false. So these are your options, that whether this program prints true, false, no output, or a compilation error. Why is it a compilation error? Why do you think that it is a compilation error? Okay, any other answers?
Ma'am, true.
Okay. So the equality operator is used here, but the equality operator is not used here on structures. The equality operator is used between integers, right? So x is an integer, and the size of operator returns you unsigned integer, or maybe long, I don't remember exactly, but it is also type of, like, it's a data type which is like integers. So here you're comparing to integers. So it is not a compilation error. So option B, option A. Okay. Okay, can anyone explain why it is option B, false? Okay, so the answer here is option B, false. Okay, now why it is so, for that I would go to some tutorial on how structures are stored in memory. Okay, yeah, so this is an example. So look at this program. Okay, here you have a structure A. Now A has these three data types, these three members. First is an integer, second is a double, then there is a short integer. So integer usually, like, it is of 4 bytes, then double is of 8 bytes, and short integer is of 2 bytes. Okay, so when this is allocated in memory, it is basically like this. First integer x is allocated, okay, which is of 4 bytes. Then double z is allocated of 8 bytes. But so when these variables are allocated in memory, then they are aligned at their like data type sizes. So if the data type is integer, so it is of 4 bytes, then this variable, like integer variables, can start only at memory locations which are multiples of 4. Okay. Similarly, a double is of size 8 bytes, so a double can start only at locations which are multiples of 8, right? So if you're like, just go here. So if this is your memory, like this, if this is your memory, okay, and redraw, just this is your memory. I'm just going to give some random like addresses here. This is a byte address, okay? One location here is 1 byte, I'm saying. Okay, so 1001, then 1000, sorry, 1000, 1001, and so on, right? Just write a couple of them. So when I'm saying that the variables are locate, like they're stored at aligned, like they're stored aligned according to their sizes. So integer variable basically can be stored from 1000 to 1003. Okay, you can store an integer here, then you can store another integer here, and then another maybe down, like, okay. But you cannot start an integer from 1000 to 1 and store it like this. Like, I'm not saying, like, in CPUs for performance reasons, they are not stored like this. They're stored aligned to their sizes. Okay, so a variable is stored in memory aligned according to its data type size. Okay, so that's why in a structure, when you have here, I'll take that example. We'll take that example and okay, let's just create another example. So we have, let's say, a structure A. Okay, first we have a character, call it X, then we have another character Y, then we have an integer Z. Now how will this be stored in memory? So your first character, which is X, it can be stored here. So since character is only of 1 byte, so they are just byte aligned. Okay, so second character can be stored here. But now when you want to store this integer Z, you cannot store it starting at location 1002. You cannot store it here also. You have to store it starting at location 1004. So that's why these 2 bytes, they are not used, and they are called padding. Okay, they're not used and they're called padding. They're just there. So Z will be stored in the next 4 bytes here. This is Z. So that's why this structure one byte, while the Yeah, but my other got hanged. Yeah. So here I am explaining that what is the size of this structure A. So the size of the structure, this has like the structure has these three members: character X, character Y, integer Z. Okay. So first character, if it is stored at say 1001, second character if it is stored at 1000 and 1001, then if integer has to be stored, then that can be stored only at address which is multiple of 4 bytes. So therefore these 2 bytes in between, they will not be used and they're called padding, and then it will be stored at bytes at locations 1004 till 1007. So that's why the size of this structure you have to calculate in keeping mind the padding also which might be used, okay, which is total of 8 bytes. So let's look at other examples from this page to, not this one, not this one, this one. Yeah, here, to understand like better, yeah, there are some more examples here. So integer X, then there is double Z, then there is short integer Y. So when you have allocated here integer X, so X is of 4 bytes, okay, which is 4 byte aligned, like its address might be, let's say, 1000, okay. But now when you have to allocate a double, the double can start only at addresses which are multiples of 8. So the next 4 bytes will be padding, like basically they're not going to be used, okay. So then double will start here, and then after that you have a short integer here, okay, which is 2 bytes. So that will be here, but then there'll be more padding here, like it has to be aligned, like everything has to be aligned according to the largest element data type which is there. So,
is there any particular reason for padding?
yeah, reason for padding is it's actually for like performance reasons. I was reading here that the CPU reads and writes memory more efficiently when they store data at an address that's a multiple of the data size. So, for example, a 4-byte integer is accessed more efficiently if it's stored at an address that's a multiple of 4. When data isn't aligned, the CPU does more address calculation work to access the data. So, like when you're doing that pointer arithmetic or anything, like, so the CPU has to calculate the data to access, sorry, addresses to access the data. So if it is not aligned, like according to the data type sizes, then it is saying that the CPU will have to do more address calculation, means it will need more power, more cycles. It is not efficient in terms of performance. Okay. So that's why it's aligned, like data is aligned according to the data type size.
But according to storage, it would be wasted, right? The space would be
Yeah,
wasted.
yeah, but that is not true for all of yeah, for that you can think, yeah, here it is there, some space wastage is there, that is true. But there is another structure, there is another uh, something called unions in C, I think. Just a second. Oh, union is a bit different, but yeah, there'll be some space wastage here, but sometimes you have to make the trade-off between space and time. So here, so since this is only for structures, like it is not like this padding is there in arrays or other data types or other this like arrays or other things there in C, it's only there in these structures. And for that also, I think there are ways, like there are ways that you can basically arrange your members in the structure in a way that the wastage is less. Like in this case here, if you first have double, then if you have an integer, and after that you have a short integer, the members are same, okay, as before, but you have just rearranged the member. Earlier they were in some different order, now they are in double, integer and short integer. Now first a double will be allocated here, right? After that an integer is allocated of 4 bytes. Now since a double starts at 8 byte aligned memory, okay, so this will finish. After that the address that you will get is 4 byte aligned, so you can immediately start X. Okay, after that you need 2 byte aligned memory, which also is available just after X finishes, so you can immediately start Y. So the padding here is only 2 bytes. Here the padding was how much, 6 plus 4, I think 10 bytes. So if you rearrange your members in a such in like intelligently, then you can also save on this padding. That is the wastage of space.
So basically, it should be in a descending order for a better
Yes,
performance.
for better that memory storage.
Yeah.
Yeah, so in this example, first you have a double, then you have a short integer, then you have an integer, then this is double, then short integer will be here, okay, then 2 bytes will not cannot be used, and the last 4 bytes will be used for the integer. So here also the wastage is only 2 bytes. It's okay. So then coming to the last problem, I'm not sure if I've answered the problem itself or not. So let's look at it again once. Yeah, so here the question was asking whether it will print true or false. So when you will here calculate the size of P1. Okay, so for this question, first number is integer. So 4 bytes like will be used. After that there is a character. Okay, 1 byte will be used. But in the end also a padding has to be added. Okay, so that everything is aligned. Like in the first example here, when we saw padding was added even in the end, so that the data is aligned. Okay, so like basically here it has to be aligned also, because it's a like they will be contiguously stored, these structures, but otherwise also the padding has to be there. So that's why this structure will be stored here in 8 bytes and not 5 bytes. Integer and character require only 5 bytes, but it is stored in 8 bytes. 3 bytes is padding. So when you so the size of P1 operator will return here. So P1 has 3 structures. Each structure is of size 8 bytes. So size of P1 will return 24. 24 like 3 into 8 divided by 3, it will give 8. Okay, so X is 8 here. Now X is equal to int size plus character size, which is 5. No, that is not true. So that's why it will print false here. So integer cannot start at 1001. Integers, since it is a 4-byte data type, it can start only at addresses which are multiples of 4, like, or you can say divided by 4, like 1000, 1004, 1008, and so on.
Now, can you please explain size of P1 again?
Yeah, size of P1. Okay, yeah. P1 is a structure here, right? Structure, sorry, P1 is an array here of structure. Okay. So here we have 3 structures in this. So this is implicitly calculated here. The size is implicitly calculated, explicitly it's not mentioned. So when you have used this initialization list here, okay, so the first two values, 1 and 90, are used to initialize the first structure. Okay, the first structure. So x is, go to my vx here. I think it has better. So it is like x. So zero structure dot x. Okay? Dot operator is used to access the member 1, which is x, is initialized to 1. Then in the same structure, zero structure, y is initialized to 90. And in the first structure, x is initialized to 62, y is initialized to 33, and so on. So there are 3 structures here in this array, and the size, it's not mentioned here, like you haven't mentioned anything here, but with the initialization list here, you can find that out. And so since the size of one structure is 8 bytes, so like first x will use 4 bytes, then this y will use 1 byte, then 3 will be padding. Then x will use 4 bytes, then this y will use 1 byte, then again 3 will be padding. Then 4 bytes, 1 byte will be used, then 3 padding. So that's why the size of this entire array is
Explain again what is padding.
padding. Just means a chunk of like, some bytes which are not going to be used to keep your data. Okay, it's just there which is not going to be used. And padding here is added so that data is aligned like as per the data type size. So I don't understand the question. Okay. So let's repeat again. This x is an integer is stored in 4 bytes. Then this y is a character is stored in 1 byte. Then since instructions they have to be data aligned, so 3 bytes are there. So one structure is taking 8 bytes. There are 3 structures in stored in P1. So that's why P1 takes 8 24 bytes. That's all we need to understand. Okay. Fine. So how do you find a career on that? I think you would have actually useful for that. The question is still using content, so it may not be clear to you what that is exactly. I'll just explain that to you. So using pointers means that assume that you have so you have this main function to use. I want to show the code just now. So I will select here. So if you have main, okay, in main you're going to use it to get the user input. Say use and n is the number for which you want to compute the factorial. N factorial basically you want to compute n factorial. So here you make scan this, right? And then you are going to let's say compute, you call a function total. You pass it and you pass something else unique, and this function should return you the total of n. Now here you should not be factorial and say that your factorial function data type is void. It cannot return anything. Okay, but definitely you have to give it n, and then give it something else, and but you still want a result here. You have to print the result here. That is factorial. So again here is to use pointers. Okay, so how can you use the pointer here so that you get something which is being computed in this factorial function in this main function here, and you can print it here. So this is going to be your program is something like this, and you have to tell me that how we use pointer here to compute. You can unmute yourself and me, or you can write your questions in the chat box and I'll read them. So we have done 11 and 15 minutes, so I would request you to write an answer as fast as possible. See,
It's tracking the address. According to the data.
I think the question is not clear to you. I'm saying you have used pointers here, and I want something which is you're going to compute the factorial of n here in this function. Okay, factorial function here, but I want that result to be arrivable in main function. But right, yeah. So basically, since I told you that you cannot return anything from factorial function, the data type is void. So you have to use pointers. You void by using structures. By using structures, you know, that's not clear to me how to use structure here. Okay, so let's get the solution here. So here you have this function for my fact factorial. Okay, it takes 2 arguments. First is the initial case, the pointer 12 mark in meter. you're going to scan, you're going to take the user input. Okay. After that, you're calling find factorial, passing for a number for which you want to compute factorial. Right? You want to compute number 1 factorial. And you're passing the address of fact variable. And you're going to modify the fact variable in the side fact function. And then since the pass the address here, so this fact variable will be modified in main as well. When you modify this in main function. Okay, you're passing here as a pointer. Okay, right? Then I will initialize it here to 1 first, and after that you're going to use the for loop, and then here basically start f1 when we say value f1, you initialize it to 1, so that actually basically there is only one location, okay, which was located here, and that location itself is getting modified whenever you do anything using this pointer. So if you start equal to 1, that location which was located here will be initialized to 1. Then inside the for loop, you're going to iterate from 1 to n. You're going to take the current value of f and the current value of fact, which is pointed by f, multiply it with I, and then you're going to change it like so that's how we're going to do it. Simply, I think like you have also written it like maybe you have done some this is a bit confusing for you. Maybe you can say okay, 2 is 1, okay, and I equal to 1, I is less than equal in I plus 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 2 q equal to into I, and then what you do is star f is equal to q. That is computed and then change the value of that f. Okay, we're going to divide f. This is also what is similar. Here you are updating the value by f every time. So okay, so any questions? If not, let's go to the next problem. Here you have to write a program to record a student merit list. So students record the student merit list. What does that mean is that here a structure variable, your first structure variable, which will have 3 members. First is student roll number, and there is student name, and then there is student score. Okay. And then you have to arrange them according to their merit. So for example, if you have 4 students, this first student in the test case is saying how many students are there. There are 4 students. And student 1 is roll number is 1, name is 3, and score is 300. And student 2 is name plus roll number is 2, name plus social, and score is 600. Student 3, the score is 750, and student 4 score is 500. So here, assuming that I get the score like higher rank, then so student 1 will be as merit 1. Okay. Then after that 900, student 3 should come at second position. Then student 2 will come at second, third position, and then student 4 will come at fourth position. So this is the should be output 1 and name and 4. So this 1, 3, it's the first like so you have to write the entire information of the students according to the scores in the descending order, right? The highest or lowest. So does this question bring any doubts like what can you use your already data or to the net. You familiar with sorting? Okay, see sorting here. Yes, we can use any of the sorting algorithms that you are familiar with. I think in this course that bubble sort, insertion sort, selection sort, I think is three. So we can use any one of those and do sort. Okay. And that's all is required for this session. Okay? It's just sorting. You have to sorting, but earlier you might have written to sort a array of integers, like integers and now you have to sort structures in it. Okay, in the data type the structure earlier it was integer, but inside that structure the decision of which structure to come earlier that depends on one member here only. Okay, that is a scope member which is in integer. So looking at the first data structure student which has members, the integer number, character name array, character array of like 20 per name, then there is 4. After that you are declaring array of structures, okay, student structures, size is 20. So like 20 students and the data can be stored in this array. But by having the number of students first, then for each student you are going to like scan the roll number names for. After that, you have to arrange the student data information in the descending order, right? From the highest score to the lowest score. So for that, here the algorithm here is using like some mapping about structure. Okay, you can write more optimized version about structure using a very very optimized, more optimized implementation of the is that the data nested for starting from 0 till the end of the array. Both starting from 0 till the end of the array. Okay, and the first pointer is pointing to scale, like I second pointer is string. Okay, and you want to compare I. So I comes from highest student, J is pointing from dearest student. Okay, assume that all the student information is in the array, just true exactly in an array. Yes, right? It's an array, and I is pointing to I student, J is J student, and you compare the score of J student with B. Okay, no. Okay, sorry. J it's no, the first anything. So the first photo is the actual number of vibrations that you do when the pulse of the maximum number of vibrations can be n, right? Yeah, and it's one is where I said, but the second one follow is for one pass of pulse. Okay, second follow here is for one pass. That pass, your first pointer is at their element, second pointer is at j plus 1 element. And you're going to compare the j element with the j plus 1 element. And you're going to compare the scores. So if the score of j student is less than the score of j plus 1 student, then you are going to swap. Okay, you're going to swap. Like if j, because you want to sorting descending order, so you're bringing the student with the highest score in front of the other. That means okay, if j student score is less than j plus 1 student score, you are going to swap. This is how you do swap. You must going to swap, and then you will reactivate this n minus 1 times. And after the loop finishes, your current will be sorted according to the necessary order. Now, if you do not understand how this is working, then I will ask you to go look at our start. Look at the implementation of sort on array of teachers, and then come back and see. And I think it's very simple. It's that similar to that, just that you are comparing the structure members and swapping the structures. After that, we just fill it. So problem number 3. So problem number 3 is write a C program to store n elements using dynamic memory application, clock function, and find the largest value. So first in this problem, we have to use, it will take as input how many elements the program, like how many elements are there from the user. And if you use n elements, you are going to use clock function to allocate an array for n elements. Okay, after that you have to find the largest element in that array. Now, how can you do that? How can you find the largest element in that array? Any answers? Can you do anything for the last question? Sorry, come again. Yeah, so you can do sort like right? You can sort according to the ascending or descending order. If you sort according to the ascending order, this one smallest to largest, then you can just sort the last element in the array. If you are sorting descending order, then you can sort the first element in the array after sorting. But sorting takes n square time. Okay, since there was 4 loops, right? Each 4 loops and n times. So sorting using double sort is taking n square time. Now, can you do something better? You need to do n square contraction. Can you do something better? But that is, how will that help you find the largest element in the array? Okay. Right. That's right. So just quickly reiterate what he said here. So we say that this is an array which you are trying to find the largest element. Maybe 10, 20, 30, 5, 6, 100, and this is short. So initially you will say, okay, you use the user max is initially first element, which is 10, and you're going to look at the next element. Okay, the next element is 10. You're going to compare it with your current max. Current max is 10 here, okay, which is less than 20, so you are swapping. This is swap. This will be 20 here, 10 will be here. Then you will compare the current max, which is will first read root number of elements. After that, you call it catalog. You're giving it needs two arguments. Right? First is the size of elements. Right? Number of elements. Then the size of each element. So each element is a float. So you're going to give it the size of float. In like it needs the size of bytes. So you're using the size of operator. After that, you return to you like memory, which is which is equal to n to size of float bytes, and each float is actually initialized to 0. Right? And then you actually a point pointer, so you have like a stick float star, and then you can use to initialize elements. Now, I will point to the first member, like I should I'll call it element three, first float in this array of floats. Okay. Then you are so now here you are going to declare here you have already created that array. Now you need to read the elements, enter values, number enter values, and store them. So this is how you are going to read using scanf and store them. After you're trying to find the largest number, as we just discussed, and so you're going to seek the largest element at all times in the location 0, like 0 position. So you're going to start from first element, I is equal to 1 till the last, and you're going to check the value of the star element in the value at first location. The value at the base address, right? Base address. So that is the first element. So if the first element is less than this higher element, then the value of the higher element, then you're going to change the value of this content. Like for here, here in this particular image, it is not doing swap. So basically, information will be lost. Some values are going to be lost. We can just swap it a little bit better. And here is just keeping an update of which is the maximum swap. And you don't need to use pointers here. You could have done it without using star. If you're not comfortable with star, you can use normal like that square bracket. That's also do this. The star of today, right? So you have to add two digits values given as input in P and S. So you will give it two values in feet and inches, and you have to add them and then output. So for example, first one is 5 feet 11 inches, then there is 9 feet 1 inch. So when you add them, so 5 feet plus 9 feet, that is 14 feet. 11 inches plus 1 inch will be 12 inches. So now since 12 inches is equal to 1 feet, you have to round off. Okay? You have to round off that and increase the feet. So you will add 5 plus 9, that will be your feet, and then 11 plus 1 inches. Now instead of giving your answer as 14 feet and 12 inches, you are expected to output 15 feet 0 inches. As another example, if your input was say 5, 11, 9, 10. Okay? I'm just changing the value here to 10. So then you go to 5 plus 9, which is 14 feet. 11 plus 10 equals to 21 inches. your answer should be 15 feet 9 inches. Now tell me how are you going to store this information? So distance here is in unit, like there are two values in distance. One is feet, one is inches. So you have done something that we can use to store information like this. And we have to store multiple information about the same thing, like the distance we have to store two things. One is feet, inches. So then what should we use? Then use phrase, but a better representation which will be questions on it. Yes. So use structure. We use a structure and with two members for this feet, inches, right? Then we have to, what is the question saying? The question is saying right to distances. Then we need to add structures. How will we add those structures? You will add a member by member. Right? You will add a first member, and the second member, and that will give you a resulting structure. Okay, let's look at this. So you're going to define a structure here, or this first member is feet, second is inch, and you have three structure variables. D1, D2, sum. So D1 is the first distance. The second distance variable is D2, and sum is the result of summing both the structures. So first, you're going to scan D1, you're going to scan D2, and you have to use dot operator to access the members, right? And D1 dot feet and D1 dot inch to take the pictures. Then, as I said, when you want to add two structures, you have to add them member by member. So, to find the sum of feet, you have to write sum of feet equal D1 dot feet plus D2 dot feet. So, in the first structure is D1, you're going to access the member feet. In the second structure, you're going to access the member feet. You will add them and then take that value in the sum structures member feet. So now you do for inch. Then, since the question is saying that if the inches are more than 12, you have to round off. So if it is greater than 12, you convert it into feet. So you check sum dot inches. If sum dot inch is greater than or equal to 12, then you are going to do sum dot inch equals sum dot inch minus 12. Okay, so that minus 12. And you're going to increment sum dot was. Okay, and then you're going to split the value sum dot feet plus sum dot inch. Is this clear? Okay. Okay, these are the questions that I have for today. If you have any doubts, I can take them now. And if you don't, then we can close the session.
The previous question is
Searching here. And it's the same way. So when we use search, it's basically a way to learn a key. Okay, a key that you want to find. Say that say okay, does this array has 5 or not? And you're going to go to each element and check is this 5, is this 5, is this 5? Yes, okay, 5 is there. Then I say okay, does this have 500? Then you're going to go back again from the starting and check each element if the element is 500 or not. Now, I don't say okay, not present, and this is yes, it is present. Now you're saying can we use searching to find the largest element in an array? So I think you cannot use it. Like if I answer your question just one line and just say no, it is not the right technique to use to find the largest element. But you can use that searching. Okay. Okay. And you understand right why you can't use searching to find the largest element. Because you don't know which is the largest element. How can you use that to search? Okay. Any other questions? This is the last or this is here. Which yeah. So since there are only two distances that you have had, okay, and the maximum number of inches in any of them can be 11, right? Like first is given the maximum value here can be 11. Second one also can be maximum 11 because it takes to 12 that you have been counted off, right? So it can be 11 plus 7 will be 20. So when you subtract 12, it will be 10. So particularly this question don't need while like for while you don't need loop here because you can only do this. So one time subtraction is enough. But yes, if you have not just two distances but many distances to add, then you have needed a loop here. Either use loop or you can use divided by 12. You can use a modular operator also, right? Any other question? All right. Okay, no, but the question that is saying, so you, so what is it saying? 12 inches is equal to 1 feet. Okay. The question is saying if you add two distance values and after adding distance values, if the inches are more than 12, then put it in terms of feet. Okay. So you have to then if the inches are set 30 inches, then you have to increment feet and then you will say okay 5 feet 1 inch. I mean I just saying here right. This is very okay. The distance is 5 11 inches, distance is 9 feet inches. space like a condition in the program than saying you have to ensure. It's not time round off. It won't cause any errors here. No, there is no rounding off here. Any other question? Let's stop recording.